Welcome to ICE Education, the only education that matters. Yeah, it is recording. So we have Laplace transform division by chi. Okay, what do you need to know with division by chi? As you can see, by the moment you hear division, it means there is something dividing it. And again, it is all about seeing what you have and what formula to use, as easy as it is. But there's a small difference when you use division by chi to multiplication by chi. Let's look at the note first. What does the note says? It says if you have Laplace of f of chi, then f of chi to this would be this, provided the limit of existence of this, and then there is a solution of this, and so far you solve and what. So anyway, let's do it. Let's do this. What does the formula says? The formula says it's all about the formula. If you have Laplace of a function f of chi over chi to be equal, I think the solution here would be integration of p to this of fu du. Don't worry about the fu formula here, you just see how it is done. We are just recalling the formula and what it means. Now they say there is a limit of existence, let's say of f of chi over chi, where chi moving towards 0. So okay, how is it done? Let's look at the example given on your note. How do you solve for Laplace of chi? Sorry. How do you solve it? Let's say you are given Laplace of sine, I'm just taking the example in the textbook, of sine 3t. Let me write nicely. Of sine 3t. Please, if you can activate the notification button, I would appreciate that. Thank you for the support. As you see by the form, you know that you have division by chi because there is a chi dividing a function here. As you can see, just the way you see it, you know this is division and this is multiplication. So what is the first thing that they say? The first thing that they say, you need to prove the existence of the limit of f of chi over chi when chi is equal to 0. How do we do that? Simple. You just call limit of chi moving towards 0 of sine 3t over chi. So what does it mean? Where there is chi, you replace by what? 0. But if you do that, you will see that this limit will give impossible, because if chi is replaced by 0, you cannot divide anything by 0 here. It's impossible. So in that case, what do we do to solve for this limit, to prove the existence? It is simple. You differentiate the guy on top and you also differentiate the chi. So what does it mean? I'm still gonna be having the limit of chi moving towards 0. If I differentiate sine 3t, it basically gives me 3 cos 3t. I hope we all fine with differentiation. If you have the differentiation of sine, just the recall formula, sine f of x, it is f prime of x cos f of x. Is just to refresh our mind. about differentiation. In this case, f of x is 3. So that's why when you differentiate, it is 3t. When you differentiate f prime of x, only 3 comes out. And then you copy cos and f of x. That's the reason why we have this one. And if you differentiate t, differentiation of t gives you 1. That's the only reason in this case this solution is 3 cos 3t. You differentiate on top and you differentiate bottom. So after doing that, you can confidently come and substitute. If you substitute t by 0, you will have 3 multiplied by cos 0. So if you type this on your calculator, definitely you have a 3 here because cos 0 is 1. Definitely, because this limit now exists, we can now solve for this Laplace. Any question before I solve on the limit here first? Please talk to me. Please talk to me. Any question? Are we good? Can we proceed, guys? Hello, talk to me. Let me check, cause I don't know if we've signed. Maybe can we proceed? Okay, thank you, Mr. Cornelius. Now, because this exists, how do we solve for this? The formula says it is integration, Laplace of f of t, basically. Laplace, let me write it. Laplace of sine 3t over t. What is the solution when you prove the existence? They say here in the formula, it is the limit of integration of f of u du, the limit of integration of p to the infinity. Now, what is the f of u that they are talking about here? It is simply the solution of the Laplace of sine 3t. Instead of writing p, you write it with u. I don't know if I'm making sense. This is what I mean. You are definitely getting the solution of sine 3t. What is the solution of sine 3t? You come to the solution of Laplace. Sine at, what does it give? It gives a over p square plus a square. A is 3, so it gives 3 over p square plus a square. A square will be 9. This is the solution of Laplace sine 3t. Because we are doing division by t, instead of writing p square here, because the formula says fu du, where we're gonna having p, we will substitute by u. So literally, what we will be having here inside should be 3 instead of p. Now you have u square plus 9, everything here in terms of du. So what is next here? What is next is we have to solve for the integration of this function. I hope you see the difference between multiplication by t and division by t. Division by t is, I see it's well cooked. There is some new information. Any question again before I proceed? So literally, after you prove, you write integration of p to the infinity of f of u. F of u is simply the solution of the function that you have here on top, but now it's going to be in terms of u instead of p. So after doing that, you need to use integration. So you need to integrate this solution for you to solve for that Laplace. So what is integration of this guy? Do you guys remember how can we integrate this one? This integration, I think it has been done in mathematics 2. But I'm here, I will remind you. I just want to check something. in one of the formula sheets that we see where it comes from. I need to scroll down. Okay, you have Laplace formula. You have GeoPivot. Oh, this textbook does not have exam formulas. Where can I get it? So give me a minute. Where's my math 3 book? I think from there I can send a picture to see what I'm talking about. Where is my math 3 book? Oh God. Fancy. On the math 3 book, I'm gonna send a picture now and the page of this integration that we've all seen. Gosh, why is it blurry? 1 minute please, so that we can all be in the same page. One more minute, my people. You should get it now. Where is it? Do I find it slow? Did you guys receive I think I've shared a picture. Did you guys receive a picture in the group there? On the group? It's going to help us to solve this integration. Okay, if you've seen the picture, do you guys see formula number 26? I'm gonna write it down so that if you don't see it there, it is written like this: integration of f prime. Ooh, what is this? Please, guys, speak to me. Speak to me. Integration of f prime of x. Down here you have f of x. Everything square. The formula is there, number 26. It is there on the formula sheet, and this formula sheet is usually given. Here you have a square. I'm just trying to copy it. The solution, they say it is 1 over a tan inverse of f of x. Let me just shift this a bit here. F of x over a. Okay, we've done this in Math 2. It's formula number 26. I know it's not written clearly, but it is formula number 6 from the picture that I've sent. So how do we solve for this integration? Remember, the limit is infinity and p. How do we solve for this integration? So you can just identify. In this case, we have u square, so which is basically our f of x square. If you differentiate u, it gives you what? 1. If you differentiate it, it gives you 1. That's the reason why you have f prime of x. So this basically fulfill the requirement of this form. I don't know if I'm making sense. And what is a? A here is what? It is a square. So if this is 9, a here is what? A is 3. So if I can rewrite this in such a way we can see this formula, I can take these 3 outside. You will have p infinity. Here you have 1 over u square plus 9 du. In such a way that this formula will fulfill the requirement of this. This has been done in mathematics too. Like I said, if you are doing math 4, they do believe that you've done 1, 2, 3. Not they do believe that, which is a fact. But as we are here, we are gonna go back, always going back and moving forward. So if we have to write this solution here, the solution says it is 1 over a. So I can write the 3 outside here so that you can see the solution. 1 over a. A here is 3. Remember, the formula says plus a square. So if this is 9, so it means a is what? A is 3. Because 3 square is 9. So f prime of x, which is 1. So the solution says what? 1 over a. So it's going to be 1 over 3 inverse tan of, what is f of x? F of x is u, of u over, what do we have? A. A is what? 3. You log like this. Now your limit is from infinity to p. This is basically integration. So you will be solving upper limit minus lower limit. If you want, you can keep these 3 outside or bring it inside to make it easier for you. So if you bring it inside, you will notice that 3 will cancel 3. So at the end, what do we have? Oh, what is this? What is this? At the end, we will have tan inverse of u over 3, where the limit move from p and infinity. So what do? We have upper limit minus lower limit. So what is the upper limit? You substitute where there is u with infinity. So you have tan inverse 1 infinity over 3 minus of the formula of tan inverse of p over 3 to say upper limit minus lower limit. So what is going on here? Let me just check. How do you... Okay. Okay. Okay, this is basically what we have. Or remember, infinity over any number gives infinity. So basically what we have is tan over infinity minus inverse tan of p over 3. So okay, it has been proven by mathematicians. Let me just draw something like this. If you have p over 2, here is minus p over 2. It has been proven that when you plot the curve of tan inverse infinity, that curves, if this is pi over 2, it moves towards, that's what it means. It moved closer to pi over 2. That's the reason in your solution, if you ever face this, they say that inverse infinity is simply equal to pi over 2. Why is it equal to pi over 2? Because the curve of inverse infinity always lay close to pi over 2. It goes toward pi over 2. That's why they say this is equal to pi over 2. So at the end, this is your final solution. I'm just gonna go back and recall my step to see we're on the same page. What is the first step when you have division by chi? You prove the existence. You have limit of this over this. If this gives impossible, you differentiate both sides on top and bottom. And then you substitute by 0, you have proven the existence. After you have proven it, now you can solve for the division by chi. How? There is a formula. The formula says that it is this f of p u du. Now, what is f of u? F of u is simply the solution of this Laplace here. But now, instead of p, we substitute by what? U. Now, we have an integration. This is basically out of the Laplace now. Now, we just use our knowledge of math 1 and 2 and 3 on how to solve the integration, which we came across the final answer of the Laplace to be this one. Any question? I would like to do another example because this is so new. Any question? Mr. Cornelius, any question, my brother?
No questions from my side.
Okay. That's good. On the other side, guys, any question? Okay, guys, can we do this example here? Hey, my laptop is low. Let me fetch the charger. Okay, guys, no problem. Let's do the example there, and yeah. And again, this is more or less like the previous case of multiplication by chi. When we have something like this, we worry about the exponential at the end only. Let's do it. Sanxi, why are you quiet? This simply means it is still division by chi, but in this case, thank you for joining us education. Like I said, it is still the same thing. This one is simply here. We're going to replace the e at the end. So normally what we do have is the multiplication by chi. Worry about the e at the end. So first of all, we have to prove the existence, and you will notice something. You will always differentiate. Why? Because this will always give impossible. If you take limit of chi towards 0 of 1 minus cos 3 chi, please, I want to say something. Do not confuse this one here and the one at the solution. Please, it's different thing. This one simply standard solve Laplace of this where you have e next to whatever function that it is, please. And I said this is how you are asked to solve any Laplace from, how do we call it again, from the general formula. They always write 0 to infinity. Don't worry much about this, please. Now, as we are here, we prove the existence. If I substitute by 0, it still gives impossible. That's why I said you will always differentiate top and bottom. So if you do that, you will have the limit moving towards 0. If you differentiate 1, 1 gives 0. If you differentiate cos, it will be minus, with this minus will be positive. So you have 3 sine 3t. When you substitute by 0, this gives you 0. At least there is a value 0 which shows the existence. In this case, when 0 is at the bottom, divide by a number. Let's say a number divided by 0 gives impossible. That's the reason why we differentiate. If you differentiate 1, t, it gives you 1. So basically here it's 1. If you differentiate this function on top here, you have this. If you replace by sine 0, where there is t by 0, you get the answer 0. So this is usually 1 mark or 2, just to prove. So it's a free mark. Now, let's come to what's more important here. It is to solve Laplace of 1 minus cos 3t over t. Now, according to the formula says that we have to have p to the infinity. Now, everything inside here should be in terms of what? U. So basically, before you bring anything inside here, if I can take you step by step, you have to solve of the Laplace of the numerator on its own. What do I mean by that? If you have Laplace of 1 cos 3t, how do you solve it? You come to your formula sheet. What is Laplace of 1? We have formulas here. Laplace of 1, which is t0, it's simply 1 over p. I hope you see it. So here, what you're going to have here is 1 over p. Minus, what is Laplace of cos 3t? You also have a formula sheet. Cos 3t is what? P over p square plus a square. P over p square plus a square. P over p square plus a square. A here is 3, so a square will be 9. This is what you get as Laplace of the numerator. But because we are doing it with division by t, instead of putting p and p, when we bring it inside here, it has to be u. So that's why you see here, we'll have integration of 1 over u minus integration of u over u square plus 9. Everything here in terms of du. I hope you see the steps. You have the function, you prove the existence. What you do is you get the Laplace of your numerator. Now you bring it in terms of u. Any question? After doing that, the remaining part is simply how to integrate. Now, with integration, again, if you remember for Math 2 or Math 1 integration, if you have f prime of x over f of x, the answer of your integration is ln of f of x. This is where we have to remember integration. In this case, if I have to integrate these guys here, let's say 1 over u. This is 1 over u, right? U is f of x. If you differentiate u, you get 1. You can see this is fulfilling the requirement of this formula. So the answer here should be ln u. I don't know if I'm making sense. Are you with me, guys? Please say something. Please say something. Are you with me? Hey, Bafetu. Hello. Mr. Cornelius. Mr. Puluso Matabi. Yolanda. Hey.
Hi.
Are you with me?
Yes.
Okay, Kaleboa. So in this case here, if I have to write the limit of the integration to be from P to what? This one will be ln U minus. Can we do the same for this guy? If we bring it aside, you have U over 2U plus 9. Now, let's see. Oh, what am I saying? What am I writing? I have U square. To be equal. If you differentiate U prime, what do you get? You get 2U. Okay, let me show you something. Do you guys agree? If I write 2U plus U square plus 9, I can write the answer to be ln of U square plus 9. Do you guys agree? Because this one is f of x, this one is f of x. They are actually fulfilling the requirement of this formula. Where if you differentiate U prime, what do you get? 2U. Please, I want you to speak here. I want to hear your take here. I don't want to be speaking alone on this side. It's very, very important. Now, for me to get this guy here, do you guys agree that I need to put 2 here for me to fulfill this requirement? And because 2 was not part of my equation, I have to bring an expression that cancels these 2, which is we call the compensation method. So in this case, the solution of the integration here will be half ln of U square plus 9. I don't know if you see. I want this to fulfill the requirement of this formula. What do? I add what I want, and now I bring the expression that cancels the expression that wasn't there. Oh, that English is good. I'm even proud of myself by saying that. So literally here, the solution here will be half of ln of U square plus 9. Any question, guys, on how we got the half, I explain it aside here. Now, remember your limit is P and infinity. So what do you do here? You will do upper limit minus lower limit. Let me write it here so that you can see. Upper limit, where there is ln, I substitute by what? Infinity. Minus half. Ln. I'll have infinity square instead of U. I will have infinity square plus 9. I close. Minus lower limit. My lower limit is P. So which is ln P minus half of ln P square plus 9. So as you can see here, everything here will be infinity, because infinity plus this will be infinity. Whatever here, whatever outcome that we have here should be infinity. Let me see again. Is that what they got? I think that's the reason they even take it aside, because the answer that we get here will be infinity. Because it is infinity, we will not consider it. So the only reason on this case why we consider it, because it is proven that inverse of tan goes towards P. That's the reason. But because this addition here only gives us infinity, we will not be focusing on this part of the equation. So what we literally have here as answer should be minus ln P minus half ln p square plus 9. Again, can I say we are done? Not sure, but we can simplify this. Otherwise, we can also stop here, but you can simplify this. Remember, if you have, now you have to remember your properties as well. If you have ln of a to the power n, you can write it as n ln a. So what I want us to do here is to bring the power of half on top using this property. Yeah, now we have to remember some properties. So we have minus, open the bracket, ln p. This video will be on YouTube. Please watch it. If you have a question, comment. I will be with you. Ln of p square plus 9. Now we are just applying some identity. Now to the power what? Half. And I'm pretty sure you guys are familiar with this. If you have, let's say, root of 2x, do you guys agree that you can write it like this? So what we're going to do now, we are moving from this to this identity. I'm showing you the identity, so I'm just changing this to this identity. So what I have here is minus ln of p minus ln of the root of p square plus 9. This is when we do it using this identity. And if you know again, what is inside here is also an identity of ln. If you have ln of a over b, it is simply ln a minus ln b. So what we are doing is we are moving from this to this. So again, have minus outside, so I know I can write ln p over what is that over skew? I can write ln p over ln of root of p square plus 9. I do believe that's what they got at the end. Let's see. Or okay. No, I see what they did. I see. Let's just let me do this like this. I know why the ln p is on, the ln root is on top. Literally, what happened here, guys, is they just first introduce minus inside. If you introduce minus inside, this one would be positive ln root of p square plus 9, like this, minus ln p. This is when you put the minus inside. It's not wrong what we did. And from here, we use the identity. That's the reason why they got ln of p square plus 9 everything over p. That's what's happening. Now, the solution is not done. Remember, because our Laplace here is coming with an exponential next to it, the answer should not be the function but a number. Like I said, because it is 1 here, we have to substitute p by what? By minus 1. So at the end of our solution, what are we going to have as answer? We're going to have ln of root minus 1 square plus 9 over minus 1. So if we have to write this with beauty, the minus will come here. I can say the answer here is ln or minus ln of root 10. I do believe that's what they got. This answer here should have minus. This is not right. Is it not right? Is it what? When you substitute p by minus 1, you have minus 1, so you have root 10. Yeah, this one is right. This is right. This Any question, guys? Any question? So I don't know if we gotta cook with you here. Nah, this one I will take it easy. This one I will take it easy. I think how long was the class? An hour and 40 minutes. I'm not sure. Yeah, an hour and 40 minutes. And I think this is where we take it for today. On Monday, I will introduce you the case where it is given to you like this, where you have to divide by p and convolutionary. So, and on Monday, I think that's gonna be, not I think, I don't know if I miss a day when I talk about my trials, but that should be the last time I do this for free. I've given you the chance to see what I can do, so it is for you to see if you want to continue with ICE education, but I do believe you will choose ICE education. So I will see you on Monday for our last free trial classes, what we're gonna do, the U thing and the convolutionary. But please, I will upload this video right away, just now. Please subscribe, share, and comment. Thank you for your time.
All right, thank you, man.
Sure, brother. Enjoy your night.